Good morning, children. So here we have the next chapter of organic chemistry, that is hydrocarbons. Now hydrocarbons, are commonly divided into three classes. One is alkane, alkene, and alkyne. Okay, you have studied this in class 10. Alkane has general formula CnH2n plus 2. Here n starts from 1, 2 onwards. Alkene general formula is CnH2n. Here n starts from 2 onwards. And alkyne has general formula CnH2n minus 2. Here also n starts from 2, 3 and so on. Alkane has carbon-carbon single bond. Alkene has carbon-carbon double bond in it. At least one double bond has to be there in the chain. And alkyne has carbon-carbon triple bond. So now today in this class, we are going to study a very important property of alkanes, that is conformation. Conformation. So what is conformation? That we have to know first. Now suppose we have a carbon-carbon single bond, carbon-carbon single bond, and valency of carbon is 4, so there should be 4 bonds attached to it. Even here there is 4 bonds, the 4 bonds. So this is sigma bond. Okay, now one property of sigma bond, it is that there occurs, just see this arrow, there occurs free rotation, okay, about sigma bond. Okay, there occurs free rotation about sigma bond. So free rotation means this carbon atom will automatically rotates. This carbon atom automatically rotates, and since this carbon atom rotates, the position of atom or group which is present here, will also change. When this sigma bond is rotating. So position of these atoms in space will keep on changing at every point of time due to carbon-carbon free rotation. And due to this free rotation, the different forms that we will get, due to this free rotation are called conformers or conformation isomer, and this phenomenon is called conformation. Now one thing you should think in this way: when we say about carbon-carbon sigma bond free rotation, then it is not that both will rotate. We have to imagine this way: one carbon atom remains fixed and the other carbon atom that rotates. Okay, if both rotates, that is not anything. So conformation means different forms of a molecule that we get due to say carbon-carbon sigma bond free rotation are called conformers, and the phenomenon is called conformation. Okay, so let us first consider, let us see what are the different forms of ethane, conformation of ethane. Conformation of ethane, ethane formula is C2H6. C2H6. So you see, as this sigma bond is rotating, the position of these three hydrogen in space will keep on changing, and different forms will get. Now the question arises: how to represent, how to show those different forms? Now Newman there is Newman projection formula. Newman projection formula is there. With the help of this Newman projection formula, we can represent those different forms. How? That I am showing you. Like these two carbon atoms, according to Newman, they represent it like this. Like this is a circle and there is a dot. Now this dot represents one carbon atom and this circle represents another carbon atom. And just see what I am doing here. Yes, so you see this dot carbon atom, it signifies that it is nearer to us. When we are looking at this ethane, this carbon atom is nearer to us, and this carbon atom, okay, it is away from us. This molecule is three-dimensional. So this is the significance, this dot, which is a carbon atom, it is nearer to us, and this carbon atom is away from us. So now nevertheless each carbon atom has 3 hydrogen. So of the front carbon atom 3 hydrogen has been shown, and the back carbon atom 3 hydrogen is shown, suppose like this. So this is one form of ethane according to Newman. So just you see the carbon-carbon bond here, this carbon-carbon bond, it is not visible here. You can make it out because this is one carbon atom and this is another carbon atom. Carbon-carbon bond is not visible, but it is understood the carbon-carbon bond is there. So this is one form of ethane. Now I am going to draw other forms of ethane. Other forms of ethane. Now as we know that the other forms appears because of carbon-carbon free rotation. Okay, so I am trying to get another form. This is symbol for rotation. Suppose we keep the front carbon atom fixed and we rotate the rear carbon atom. The backside carbon atom we rotate. And let us rotate it by 60 degrees. Let us rotate it by 60 degrees. Why 60 degrees, that you will understand later on. So suppose first front carbon atom is fixed, the rear carbon atom they are rotating it by 60 degrees. Then this hydrogen will come here. This hydrogen will come here. This hydrogen will come here means actually this hydrogen will be below this hydrogen. Similarly, this hydrogen will come here, means it will be below that hydrogen. So, due to 60 degree rotation, they will come, this hydrogen will come below it. So that I am now showing. We are keeping the front carbon atom fixed. Keeping the front carbon atom fixed. So this hydrogen will come below it. So that we are showing it by this way. So this hydrogen is below that hydrogen. This is how we represent it. Similarly, this hydrogen will be below this. So this hydrogen will be below this. Okay. Now, so we see we have got two conformers. One is this and one is this. Now this forms, has got name. This form of ethane, it is called staggered ethane, and this form of ethane is called eclipsed ethane. You can make it out easily why it is called eclipsed ethane. It is because, as you look from this side, this hydrogen which is behind this hydrogen will not be properly visible. That means this front hydrogen is eclipsing the back hydrogen. That's why it is called eclipsed ethane, and this is called staggered ethane. Everything is visible, so staggered ethane. And so again suppose if we rotate it by 60 degree, can you tell me what we will get? Okay, you can easily see, if I rotate it by 60 degree, again we will get the staggered form. If I so in this way, every 60 degree rotation will result in these two forms. Now it is not that we will rotate it by only 60 degree. Okay, we can rotate it by any degree. We can rotate it by 1 degree, we can rotate it by 2 degree, 3 degree, 4 degree, 5 degree. So that those things also happens, and like if I ask you how many different forms of ethane will be possible, the answer will be there are infinite forms. There can be infinite forms of ethane. Suppose one more form I am drawing for you. One more form I am drawing. Suppose here we are rotating it by say 1 degree. Just I am rotating it by 1 degree. So on rotating by 1 degree, what form we will get? This is the front carbon atom. I am keeping the front carbon atom fixed, and this is the hydrogen, and the back carbon atom will be displaced by just 1 degree. So previously it was here, so maybe it will be here, just 1 degree. This one will be slightly here, this one will be slightly here. So on rotating by 1 degree, it becomes like this. So 1 degree, 2 degree, so infinite forms will be possible. And suppose if I ask you how many forms are possible between staggered form and eclipsed form, then answer will be infinite. There will be infinite forms between staggered and eclipsed, and all these conformation between staggered and eclipsed, okay, they all are known by this name. It's called skew conformation. So this is staggered, this is eclipsed, and these are skewed. So two extreme conformation. Why I have taken 60 degree, in order to explain you that these two are two extreme conformation, and all conformation between these extremes, they are called skew conformation. Now the question that arises, suppose if I ask you, between these two forms, which one is more stable and why? Stability, which one is more stable and why? Now the answer is, this one is more stable, this one is more stable, this one is less stable. This is more stable. More stable means less energy. So this is less energy. This is having less energy, and this is having more energy. So we need to find out why this is more stable, or why it has less energy, or why this is less stable, why it has more energy. This we need to find out. So the reason is that you can see here in case of eclipse form, as you know, this hydrogen atom is in front and this hydrogen atom is just below it, and these two hydrogen atoms are therefore close to one another, and there will be repulsion. There will be repulsion between these hydrogen atoms. There will be repulsion between these hydrogen atoms, and because of this repulsion, this molecule will get more energy, and it will not be stable. On the other hand, you can see here the front hydrogen and the back hydrogen, they are maximum distance apart, maximum angular distance apart in the staggered form. So repulsion will be minimum here. That's why it is most stable. Okay, form of all different conformation of ethane, and that's why it has less energy. So this is the thing about energy. Now there is another form by which we can represent this conformation. There is another form possible. There is another projection formula is there. That is called sawhorse. Sawhorse projection formula. That I am going to show you now. So suppose this staggered and eclipse form only. Now I am trying to show you according to Sawhorse projection formula. Now according to Sawhorse projection formula, the carbon-carbon bond, it is shown. Suppose this is how carbon-carbon bond is shown in Sawhorse. In case of Newman, it was not shown, but here it is shown. Okay, and say these are the three atoms of hydrogen. Three atoms of hydrogen. So this carbon is having valency 4, 1, 2, 3 and 4. Okay, and of another carbon atom, the staggered form, we will be showing like this. One hydrogen here, one hydrogen here, one hydrogen here. This is the staggered form of ethane, okay, according to Sawhorse projection formula. Now, in case of Sawhorse, in case of Newman, we see in this way, whereas the line of sight, in case of Sawhorse, it is this, in this direction we see the molecule. In this direction we see the molecule. So what will happen on 60-degree rotation? Now on 60-degree rotation we get this one. So this one according to eclipse, this one according to Sawhorse, how will we represent this one? Suppose we are keeping this carbon atom fixed. So carbon atom fixed, and this one will rotate. So this one on rotating will come here. So then that one we show it like this. This one has come here. This one will come here. And this one will come here. So this one has come here. This position of this. So on 60-degree rotation, we get according to Sawhorse, okay, this your staggered form is staggered. This is this is eclipse form. And this is staggered form. Okay, but the energy difference. Okay, this is one very important thing to note. The difference in energy between these two forms, is very less. So that's why there occurs this conversion, automatically, and this conversion is very rapid, and that is the reason why we cannot separate. These different forms of ethane. We cannot separate. Suppose we have got in a container ethane. So the ethane molecules inside, will keep on changing always from one form to another. Inside that container, it will keep on changing, and since the energy difference between them is very less, okay, we won't be able to separate them. For example, it cannot be done that from there, in one container we have only staggered ethane, in another container we have only eclipse ethane. That is not possible because there occurs a rapid interconversion between one form to another. This is one thing you have to remember. So the different forms of ethane, the conformers of ethane, we cannot separate. Now, children, I will ask you to find out about one term here. Okay, you should find it out from your NCERT book. Okay, what is torsional strain? What is torsional strain? Okay, that you will try to find out. What is torsional strain? Now, in the same way, I have shown you for ethane. You can also try to draw the conformation of, say, other hydrocarbons. Say, suppose after ethane, suppose you are asked to draw the conformation of propane. This is propane. Conformation of propane. Suppose you are asked to draw the conformation of butane. Conformation of butane, and so on. So a question that arises is which carbon carbon atom rotation you should consider. So this is carbon is there, this is carbon is there, or here this carbon is there, this carbon is there. Which carbon rotation you should consider to get the different form? That is one thing that you should know first. Now here, in this case, you see this bond and this bond is same. This bond and this bond is same. So in any one of them, you can consider rotation. Any one of them. So I'm just helping you in this way. You can do it. So you think this molecule in this way. Suppose we are considering about this rotation. So this is the carbon-carbon bond. So with these 3 hydrogen, 1, 2, 3, and the groups which are attached to this carbon. What are the groups attached to this carbon? So one is hydrogen, the other one also is hydrogen, and the fourth one, which is methyl. So this molecule you can think in this way, and to get the conformers, you consider the rotation about this carbon-carbon bond. So rotating about this carbon-carbon bond, you can get the different forms, and you can represent them in Newman or in Sawhorst projection formula. If you want to draw the conformation of butane, since this is the middle carbon atom, you have to consider the rotation about this carbon-carbon bond, and you will get the conformations. Okay. Now, in the end, I would like to consider one thing. This conformation is there, is possible only with alkane. Okay. This is not possible. This phenomenon is not possible in case of alkenes. Not possible in case of alkenes. You need to find out yourself why. This phenomenon is also not possible in case of alkynes. Okay. So you try to find out. If you cannot, then I will tell you in the class. So this conformation is only applicable in case of alkenes. So children, so this much from now. You watch these videos very properly, sincerely, and we are going to discuss on this more in our classes today. Thank you very much.